We now discuss the solution of a problem from the section Differential Calculus, and this present problem is on indeterminate form. This question has appeared in the joint entrance examination main held on 27th July 2021 in the second shift. The problem given is the value of limit extends to 0 of this quotient, where the numerator is x by the denominator is the 8th root of 1 minus sin x minus the 8th root of 1 plus sin x is equal to. We are given the four options here. We have to take this quotient, take the limit as extends to 0, find out its value. So we now discuss the solution of the problem in detail. That's our problem. And the solution is limit extends to 0 of the quotient. The numerator is x by the denominator 8th root of 1 minus sin x minus 8th root of 1 plus sin x. And as extends to 0, the numerator is 0, the denominator is 0. Therefore, it takes a 0 by 0 form, and we know that it is an indeterminate form. To evaluate this indeterminate form, we multiply and divide by the rationalizing factor of the denominator. So we rationalize the denominator. The rationalizing factor of the denominator is the 8th root of 1 minus sin x plus 8th root of 1 plus sin x. We multiply and divide by the rationalizing factor. That is the quotient, and this is we are multiplying and divide by the rationalizing factor. Now, when you multiply in the denominator, you will get the 4th root of 1 minus sin x minus the 4th root of 1 plus sin x. And that will be x by the 4th root of 1 minus sin x minus 4th root of 1 plus sin x, and this factor will remain. So this is the one multiplied by this. And the limit of the product is equal to product of their limits. So limit extends to 0 of this factor multiplied by limit extends to 0 of this factor. This is what we have written. And limit extends to 0 of this one, the 8th root of 1 minus sin x plus 8th root of 1 plus sin x is 1 plus 1, 2. And 2 times this one. Limit extends to 0 of x by the 4th root of 1 minus sin x minus 4th root of 1 plus sin x. As x tends to 0, it again takes the 0 by 0 form. We rationalize. To rationalize, we will multiply and divide by the 4th root of 1 minus sin x plus the 4th root of 1 plus sin x. We do it in the next slide. So that is 2 times. We rationalize. Now, now we multiply in the denominator. When you multiply, you will get the square root of 1 minus sin x minus the square root of 1 plus sin x in the denominator. Then you will get 2 times limit extends to 0 of the 4th root of 1 minus sin x plus the 4th root of 1 plus sin x multiplied by limit extends to 0 x by multiplying the denominator, you get this one. You will get this. And 2 into the limit extends to 0 of this is 2 into 2. Limit extends to 0 of x by square root of 1 minus sin x minus square root of 1 plus sin x. Again, it takes the 0 by 0 form. Right. We rationalize the denominator. We continue in the next slide. So, 4 times limit extends to 0, x by square root of 1 minus sin x minus square root of 1 plus sin x. Multiply and divide by the rationalizing factor of the denominator. The rationalizing factor is under the square root of 1 minus sin x plus under the square root of 1 plus sin x. When you multiply in the denominator, you will get 1 minus sin x minus 1 plus sin x. And this first factor will be as it is. Then it will be 4 times limit extends to 0. This one under the square root of 1 minus sin x plus under the square root of 1 plus sin x into limit extends to 0 x by, when you multiply, it will be 1 minus sin x minus of in brackets 1 plus sin x. And when you take the limit of the product is equal to product of their limits which you have applied. Limit of this is 2, and here 1 minus 1 cancels and you are left with in the denominator minus 2 sin x. This will be 4 into 2 to limit extends to 0 of this, and cancellation takes place. 4 into 2 limit extends to 0 by minus sin x, that is minus 2 times of sin x. Cancellation takes place and you will get minus 4 times limit extends to 0 of x by sin x. And the answer is minus 4 because limit extends to 0, sin x by x is 1. So this is minus 4. So the answer is minus 4. Let's look at our options. Our answer minus 4 appears against option 1. Therefore, our answer is option 1. So that is the a very simple and straightforward question from the differential calculus on indeterminate forms. I am sure that you have understood the solution of this problem and go on working out some more typical problems from the subsection indeterminate forms and the usage of L'Hopital's rule. That will be an interesting and important section. I wish you all the best. Thank you.